I'm going to now try and work through these practice problems that I have put in WebAssign in order to prepare you for the exam. So hopefully I can work them all correctly and explain what I'm doing, and then as you work through them, if you get stuck, you can watch these videos. So let's see how this works. I'm going to first share my screen, and I'm going to pull up the WebAssign right here. So you can see here, practice test number 3 problems. This looks a little different than your screen because this is, I'm the instructor. So I'm going to pull up those problems. Now I may or may not show this screen because I want to work them out. So for instance, problem number 1, find all solutions of the equation. So here's problem 1. So what I'm doing now is a little bit like what your scratch paper should look like when you take the exam. So let me go back now. Now here are the 2 things I'm going to be using, and you'll be able to use these 2 on your exam since it's open notes. The first is that unit circle. Of course, I have it memorized pretty much. Well, I do have it memorized. I've done it so much. But you can use this, which you will need this. And then the second thing we'll need to use for a lot of these problems is this formula sheet. Sum and difference formulas, the double angle, the half angle. So I've got these handy that I can look at if I need to. So find all the solutions. So if I think about this, x is an angle. I'm looking for the angle where the sine is square root of 3 over 2. Now you can look at your unit circle, or for me, I pretty much know that it's the pi over 3 angle. Down here is 5 pi over 3. So I would say x, you take your first angle. Now we're looking for all solutions, not just one trip around the unit circle, but every possible solution. So you take your first solution and you have to add the 2 pi n. So this 2 pi n keeps taking you around and around and around. And then the second solution would be 5 pi over 3 plus 2 pi n. So hopefully one of the solutions is this. So let me go back now. And actually for me, I can put the key up here. Let me just do that, make sure I don't make any mistakes. Actually, what I should do is, let's decide which one it is. Don't be fooled now. Look at this first answer. Pi over 3 plus pi n, 2 pi over 3 plus, you see the pi over 3 and 2 pi over 3, you think that's correct? But look, we're adding pi n and pi n. You need to actually add 2 pi n. So look at the second answer. This first one looks correct, but it's not because of the pi n. You need to choose this one because of the 2 pi n. And when we actually look at the answer, that is correct. All right, the second problem. Find all the solutions. 5 cosine t equals -5. Let me write it down, then we can work through it. 5 cosine t equals -5. Now, if you recall, when I lectured on this, I said it's really a 2-step process to solve these equations. So really, I'm trying to solve for t. T is actually an angle. Two-step process, right? First, get the trig function by itself. And then after that, you can actually solve for the angle. So to get this trig function by itself, I need to get rid of this 5 here. I'll divide both sides by 5. So now I've solved for the trig function. Now I actually need to solve for the angle t. And I simply ask myself the question, what's the angle where the cosine is -1? You can look on your unit circle. Remember, cosine is like x. X, or the cosine, is -1 over here. What's this angle? That angle's pi, but of course we have to take into account every possible solution. So it's really pi plus 2 pi n. Now if you think about the unit circle, that's the only place on here where the cosine is -1. Over here, the cosine's 1. So there's actually just one solution. So now if we go back at the answers, I hopefully will see one where it says pi plus 2 pi n. So if I go back, so here, pi plus pi, that's not correct. It should be pi plus 2 pi n. So it looks like this one's correct. Looks like the third one, I believe, is correct. If I go and click on the key, and that's correct, pi plus 2 pi n. All right, problem number 3. Find all solutions. Tangent of theta equals square root of 3. So another solving a trig equation. So here's problem number 3. Trying to find theta. I've already got the trig function by itself, so now the question is, what's the angle where the tangent is square root of 3? Tangent's a little tricky. What you have to do is, you have to think to yourself, tangent is really sine over cosine. So I have to go find an angle where the sine over the cosine equals square root of 3. Now the only time I have square roots of 3 are these over here. But now since sine is on top, hopefully you do this enough, you see, I need the angle where the sine is square root of 3 over 2 and the cosine's 1/2. Where does that occur? That occurs, and I need it to be a positive 3. So I need sine and cosine to either both be positive or both be negative. So that happens at pi over 3, because at sine pi over 3 over cosine pi over 3, square root of 3 over 2 over 1/2. If you want to simplify this complex fraction, you write the top fraction multiplied by the reciprocal of the bottom fraction. Those 2's cancel. So the tangent of pi over 3 is this. So that's going to be a solution. The other one is going to be here at 4 pi over 3, because in the third quadrant, the sine and the cosine are both negative, but when you put them in the fraction, the negatives cancel, make it positive. So there's really 2 solutions. Although tangent's a little tricky. Let me write it out, and then I'm going to show you what happens, because it ends up with tangent. Instead of 2 pi n, it repeats every pi n. So if I write it like this, actually, look what happens when n is 0. This theta is pi over 3. This one's 4 pi over 3. but when n is 1, pi over 3 plus pi is 4 pi over 3, and they start repeating. It just turns out for tangent, because it repeats every pi, I think this is going to be redundant. I think by just using this one, it's going to also cover all my possibilities. So my guess is the answer should be pi over 3 plus pi n. Like I said, tangent's a little tricky. So I see here pi over 3 plus pi n. Look at all these options. There's only one angle. So the third one down, I'm going to guess. So if I stick in the key, and that's correct. All right, so number 4. Another solving a trig equation. 3 secant of beta equals 6. Let me write it down. Number 4. Three secant of beta equals 6. Let me try to work it out. So there's problem number 4. Once again, let's solve for the trig function, divide both sides by 3. Now, here's what I've always told you about secant and cosecant and cotangent, sort of what I think of as the minor trig functions. I hardly ever work with them. As soon as possible, I'm going to change these to sine, cosine, or tangent. Secant gets paired with cosine. If you're given a secant, how does it turn into cosine? Well, first of all, I need to think of the secant as a fraction 3 over 1. To get to cosine, you simply, whoops. Sorry, I can't divide by 3. I knew this wasn't one of my special angles, so I knew I had a problem here. So now I flip this, and now I'm really solving cosine of beta is 1/2. So once again, the real question is, what does beta equal? So now it becomes pretty straightforward. What are the angles where beta is the cosine of beta, the cosine, what's the angle where the cosine's 1/2? It's back up here at pi over 3, and positive cosine is quadrant 4, and this is actually 5 pi over 3. So my answer is going to be pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. This is what your scratch paper should look like as you're doing the test, what you're going to send to me. So pi over 3 and 5 pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n. Looks like the second one down, I believe, is correct. Yep, that's the correct answer. All right, so far so good. Although I made a little math there, but I was able to catch it because I knew my number looked sort of funny. All right, look at this one. All right, this one's going to be a little more involved. 10 cosine of 2 theta. So number 5. 10 cosine of 2 theta minus 5 square root of 3 equals 0. I want to make sure I copy it correctly. All right, so this is getting a little more complicated. Now notice one of the big differences now, all the problems up until now inside the trig function has just been an angle. If we look back, look at these first 4 problems. Sine of x, angle is x. Cosine t, angle of t. Tangent of theta, the angle is theta. Secant of beta. But look here, inside the trig function, cosine of 2 theta. So that's going to add a complicating factor. Plus we've got this other stuff. Now I'm going to go ahead, I'm going to solve this equation for cosine of 2 theta. So let's try and get cosine of 2 theta by itself. So ultimately, the solution is going to be what is theta equal to? Well, let's get 2 theta by itself. So I'll add 5 square root of 3 to move this to the other side. I'll divide both sides by 10. 5 square root of 3 over 10. Of course, 5 over 10 reduces to... So this is something that looks familiar, right? Square root of 3 over 2, we see that a lot. But the problem is I've still got this cosine of, if this was simply cosine of theta equals square root of 3 over 2, then I would almost be done. But I don't have that. I have cosine of 2 theta equals square root of 3 over 2. So what we're going to do is, if you recall, this is where we do the U-Substitution, where I'm going to define this variable u, and I'm going to set it equal to whatever is inside the trig function. Because when I do that, then I'm going to rewrite this equation, and instead of thetas, I'm going to put this u in here. So the equation, instead of cosine 2 theta equals square root of 3 over 2, it's cosine of u. So now I've sort of gotten rid of the 2 inside, and I've got this down here where I can think of this u as an angle. I can now solve this little equation here. You simply say, okay, what's the angle where the cosine is square root of 3 over 2? And because I know my unit circle pretty well, I know it's pi over 6 plus 2 pi n. And is also 11 pi over 6 plus 2 pi n. There's 2 angles. However, so it feels like I've sort of solved this, but I haven't really solved it yet because look at up here, the original problem. They're wanting to know what is theta. I've solved for this u, but someone says, what's u? We're trying to figure out theta. Well, u is what we use as a way to eventually solve the equation. Once you solve for u's, then you go back to where you originally defined your u. And you take the first u here, and you write down your solution for u here, and then you go up here and you say u also equals 2 theta. So if u equals this, u is also 2 theta. And now you take this equation and you get theta by itself, and then you will solve the equation. So I have to divide both sides by 2. So you get pi over 6 divided by 2 plus 2 pi over n divided by 2. When you have a fraction over a number, the shortcut is this number just goes up here in the bottom. So this becomes pi over 12. The 2's here cancel out. So my first u solution, when you switch it back to theta, actually gives this. Now I need to do the same thing for my second u solution. So then I say, here's my second u solution. It was 11 pi over 6 plus 2 pi n. U equals that, but u also equals 2 theta. So I divide both sides by 2. Theta is 11 pi over 6 divided by 2. plus 2 pi n over 2. This becomes 11 pi over 12 plus pi n. So actually two solutions for theta. Looks like pi over 12 plus pi n, 11 pi over 12 plus pi n. So hopefully, when I go look at the answers, that's one of my choices. And hopefully it'll even be the correct one. So this is problem number 5. I'm looking at pi over 12 and 11 pi over 12. Here's pi over 12, 11 pi over 12. But look at here, it's not plus 2 pi, it's plus pi n. This one's not correct. What have I got down here? Pi over 12 plus pi n, 11 pi over 12 plus pi n. So actually it's this one. Looks like it's the fourth one. So I'm going to turn on the key. And according to us, we're hoping the fourth one is correct for number 5, and it is. So it looks like we did the problem correctly. How many of these do we have? 20 something? Oh boy. How about, okay, I'm ready for problem 6. So let me write this one down and see if we figure out this one. So number 6 is the cosine of x minus pi over 8 equals -1. All right. So let's switch back so you can see me work it out. So there we go. Now this is the same idea as the one we just did. I've got the cosine, and here's the stuff inside the cosine function. I'm going to have to do a U-substitution. So the trig function's by itself. I'm ultimately trying to solve for the angle x. But what I'm going to have to do is, in this case, you let u equal to everything inside the trig function. In this case, it's x minus pi over 8. So if I do my substitution, instead of this, I can just call it u. And now I have this equation to solve. And this one's not too bad. I'm looking for the angle u where the cosine is -1. It actually only occurs once at the angle pi, so our general solution is pi plus 2 pi n. Of course, now I need to switch this u back to x. And I use this definition of u. So if u equals this, u also equals this. So I just write them together. And now I can take this equation and solve for x. So I got to add pi over 8 to both sides. So x equals pi plus 2 pi n plus pi over 8. Now this n is like a variable, but this pi and this pi over 8 I can combine. As a matter of fact, if I'm going to add those together, I have to get a common denominator. So pi is the same thing as 8 pi over 8. So I add these together, and what I've really got is 9 pi over 8 plus 2 pi n. I hope that's one of the solutions and it's correct. 9 pi over 8 plus 2 pi n. So this is number 6. Maybe I'll go to number 10 and then stop and start a new video. So number 6, I'm looking for 9 pi over 8 plus 2 pi n. Here's 9 pi over 8 plus 2 pi n. Looks like the first one is what I think is correct. I go back and check. Number 6. Yep, that's correct. All right. Like I said, let's go up to number 10, then I'll take a break, give my voice a rest. So number 7, three secant squared alpha minus 12. Three secant squared alpha minus 12 equals 0. All right, once again, solving a trig function. So now here the different thing is, first of all, it's a secant, but it's secant squared. And just so you know, these really mean the same thing. It's just the world of trig. Instead of writing it like this, they like to put the squared in here after the trig function. But it means basically the secant squared, the secant of alpha, the whole thing squared. So what I'm going to do is two-step process. I'm going to solve for the secant of alpha. Although in this case, I'm going to solve for the secant of alpha. Then I'm going to switch it to cosine. And then finally try and solve for alpha. So let's get the secant squared by itself. Add 12 to both sides. If I want to get the secant squared by itself, divide both sides by 3. Now what I really want, I don't want secant squared, I really want secant of alpha. So what do you do when you have something squared and you don't want it squared anymore? Take the square root, right? Now I can take the square root of this equation as long as I do the square root of both sides. So now I've solved for secant of alpha. Now here's where a lot of students will mess up. A lot of students square root of 4, they want to write 2, and they think they're done. But you got to remember in math, when you take the square root of a number, there are actually 2 solutions, plus and minus 2. So really, just to be very clear, we really have 2 solutions to solve. Actually, before I do this, I need to switch this to cosine. So basically, if secant of alpha is plus or minus 2, I turn it into a fraction. And then when I switch it to cosine, I flip the secant. And it comes really plus or minus 1/2. So really, what I have is cosine of alpha is 1/2. Cosine of alpha is negative 1/2. So now I've got to go around the unit circle. Let's first do cosine of alpha is 1/2. Where's the cosine 1/2? Well, I know my unit circle pretty well. You can look if you need to, but I know it's going to be pi over 3 plus 2 pi n. And also 5 pi over 3 plus 2 pi n. Now how about cosine of alpha equals negative 1/2? It's 2 pi over 3 plus 2 pi n. And finally, negative 1/2 is also, so actually I have 4 different angles, pi over 3, 5 pi over 3, 2 pi over 3, 4 pi over 3, all with 2 pi added to it. So that is what I propose to be the solution to number 7. We can see all right, so now here they do some tricky things. They don't have it written like I do. So let's try and figure out which one of these is the same as mine. So they've got I know for sure it's not this one or this one. My guess is this is a case where you have to sort of maybe work it out. Start plugging in ends. So let's just say, let's see how this first one works out. So I'm gonna, on my piece of paper, I can't show it to you. I'm gonna look at n's and then look at my solution. So when n is 0, and I'll show you this later on, I have two solutions, pi over 3 and 2 pi over 3. When n is 1, I have pi over 3 plus 2 pi, which is 7 pi over 3, and well, this actually is sort of strange because here they're adding 2 pi and here it's pi n, so that's very suspicious. I'm pretty sure this one's probably correct. So let me start out, let me go do that last one. I'm going to do it here, then I'll show you what I'm doing. I'm making a column where I'm going to start at n equals 0 and figure out the solution. So when n is 0, I'll write the whole thing here on this piece of paper and I'll show you what I'm doing. So that last solution is pi over 3 plus pi n and 2 pi over 3 plus pi n. So here's what I think might be the correct solution. Here's what I'm already looking for. I'm looking for, if you think about it, it's all the denominator of 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. All 4 of them in the unit circle are solutions. So I'm looking to see if that's what this gives me. The only way I can know for sure is I start stepping through my values of n. So when n is 0, I plug in 0 for here, and you get pi over 3. When you plug in 0 here, you get 2 pi over 3. So those are both solutions. What happens when n is 1? Pi over 3 plus pi, if you do the math, it's 4 pi over 3. And then you plug in 0 here, 2 pi over 3 plus pi is 5 pi over 3. So there's my 4 solutions. So this is the one I believe to be correct. That was a little painful and messy, but unfortunately, we didn't have a choice because of the way they wrote the answer. So I believe the answer is going to be this last one here. So turn on the key, number 7, and it is. All right. About number 8. Oh, all right, number 8. Let me write it down. Cosine 2x minus pi over 9 equals 0. Now look at the instructions though. We switch now. Here, the one before, find all solutions here. Find all solutions in the interval 0 to 2 pi. So now we're not having to do the thing with the n where we have to add on the 2 pi n. Now we just are looking at all the angles between 0, starting at 0, and going up to 2 pi. So it's not going to quite be as messy. All right, let's see if we can solve this. Once again, I've got the trig function by itself, and I got some messy stuff inside. So when we have this, we always do our U-Substitution. So the equation now becomes cosine of u equals 0. This is pretty easy to solve. As a matter of fact, there's only one angle where the cosine is 0, and that's 0. Now you could think it's 2 pi, but the problem here is well, let's do this just to be safe. You know what we have to do? The more I think about it, I need to actually do the 2 pi n for now. And you're going to see why in a minute. So let's for now, I need to do the repeating stuff. And then eventually, when I start getting actual angles, I'll just get the ones in between 0 and 2 pi. So what I said before wasn't quite true. It is true. My answers are going to be between 0 and 2 pi. But when I do the problem, I still have to include the 2 pi n for now. Although this is actually wrong. You guys are probably thinking, cosine is 0 up here and up here. So it's really going to be pi over 2 plus 2 pi n and 3 pi over 2 plus 2 pi n. So those are the solutions. The cosine of u is 0. Here's my other u. So I also take it and set it here. Now I need to solve these two equations for x. So let's do the first one. This looks pretty messy, actually. I'm going to add power over 9 to both sides. Once again, I'm trying to get x by itself. So I'll say pi over 9 plus pi over 2 plus 2 pi n. Let's go ahead and combine these. So common denominator, this is very messy. It's going to be 18. 2 pi over 18 plus 9 pi over 18 plus 2 pi n. So that's 2x equals 11 pi over 18 plus 2 pi n. Divide both sides by 2. You end up with 11 pi over 36 plus pi n. That's actually my first solution. I've got to do the same thing now for 3 pi over 2 plus 2 pi n. So if I have, we'll take this one, so add pi over 9 to both sides. So I get 2x is pi over 9 plus 3 pi over 2 plus 2 pi n. I need to add these together. Common denominator of 18, 2 pi over 18 plus 27 pi over 18 plus 2 pi n. So this is 29 pi over 18 plus 2 pi n. Now divide both sides by 2. Over here I get 29 pi over 36 plus pi n. So those are now my two solutions for x. Now I do the thing where I start stepping and counting my n's and finding these solutions, and I keep increasing the n's until my angles get to be bigger than 2 pi. So I start with n equals 0. When I plug in n equals 0 into here, I get 11 pi over 36. When I plug n equals 0 over here, I get 29 pi over 36. Both those angles are between 0 and 2 pi. If you think about it, 2 pi with the denominator of 36 is 72 pi over 36. So these are both less than 2 pi. So now I set n equal to 1. I do the same thing. So now I have 11 pi over 36 plus pi. If you change the pi to 36 over 36, and I think you end up with 47 pi over 36. You plug in 1 up here, You're going to get 36 pi plus 2965, I hope in my head. Now what happens when n is 2? Well, it's pretty clear. When you put 2 in here for n, you get 2 pi plus this. Obviously, all of a sudden, you're bigger than 2 pi. The same thing here. So you stop. N has to be 0 and 1, and you're done. Now, that was a lot of math. I've got my fingers crossed that this is one of the answers. So let's go back and see. I've got it written down. This is problem 8. Oh, this is one where it's not multiple choice. So let's just click on the key and see if our answer matches up. So this is like a fill in the blank. And I'm looking 11 power of 36, that's the same, 29 power of 36, 47, and 65. So, wow, we actually got the correct answer. That was pretty tricky, so that's good. So now, let's do 9 and 10, then I'm gonna take a break. Hopefully these are not too ugly. 9. So 9 is 8 minus 32 cosine squared of t. It says, once again, t should be between 0 and 2 pi. All right, so once again, let's get cosine squared t by itself and then get it down to cosine t and then go from there. So let's add 32 cosine squared t to both sides to keep both sides positive. Divide both sides by 32, which is 1/4. So I've got cosine squared of t is 1/4. But I want cosine t, so what do? Square root of both sides. Now the first thing you realize is the square root of a number is plus or minus. When you have a square root of a fraction, you just take the square root of the top and the square root of the bottom. What's the square root of 1? It's just 1. What's the square root of 4? It's 2. So actually my solution is cosine of t is plus or minus 1/2. Now, what are the angles where the cosine is either plus or minus 1/2? As it turns out, the cosines are 1/2 at pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So it's all the angles with 3 in the denominator. The cosine is either plus or minus 1/2. So I think that's it. Wow, a lot simpler than one before. So let's see for number 9. If we were successful. Once again, it's a fill in the blank. So I'll go turn the key on. And then we'll go look at the answer. And I'll tell you whether the answer key is the same as what we figured out. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Yep. All right, let's do number 10, and then we'll take a break. So number 10, a little bit of an equation. Now we've got two sine squared u equals -1. Once again, the angle U should be between 0 and 2 pi. All right. Now this is something we've not seen yet, where there's two terms, both have the sine U, and this one's sine squared, this one's sine U. So what you do to solve a problem like this is you have to get everything on one side and the other side equal to 0, and then you typically have to factor. So even though they're trig functions, we can still use the idea of factoring. So let's move everything to the left-hand side. Now what you have to do is, even though these are trig functions here, in your head, think of this trig function as just sort of a variable. It's almost like, what if I said, let's solve this equation. 2x squared minus 3x plus 1. That's what we're really doing. We're thinking of this trig function as just like a variable. So here's a trig function squared, sort of like x squared. Here's a trig function by itself, that's x. And we're going to solve this by factoring, and we basically think of sine of u as like our variable. Now, this is a trig class. A lot of you may not remember how to factor very well if it's been a while. So I'm just going to do this. I'm not going to take a lot of time to explain what I'm doing. Here's the way I like to factor these. I do this thing called, my product is this 2 times this 1, and then my sum is the middle coefficient. Now I can think of two numbers that if I multiply them together equal 2, but when I add them equal -3. And actually, -1 and 2, if you add them, you take the sum, it's -3. But when you multiply them, take the product, it's 2. And that meets my requirement. So then the way I do that, I'm going to go ahead and use this. I write my first term, I copy it, and I write the last term. This middle term gets split up into my two factors. So -3 is going to be split up between -2 plus -1. So it's 2 sine u minus 1 sine u. So it's like this thing gets broken up. And now, you know what we call factor by grouping. I take these first two terms. The common factor is 2 sine u minus 1. Here, there's no common factor. So I just subtract sine u minus 1. And then you notice these parentheses are identical, so you factor out the whole parenthesis. Once again, this is sort of hardcore algebra, so if you're not quite following this, it's probably been too long since you did a bunch of factoring. Anyway, once I factor, I get this. Now the solution is, you take each of these parentheses, and you set them equal to 0, and you solve it. So the first one says sine u of 1. The second parenthesis, I say equals 0 and I solve it. And when you solve that one, you get 1/2. So all that is to get to this point. Now these are going to give me my solutions. So actually, I think I have room here because I know these. So if I think about angles between 0 and 2 pi, what are the angles where the sine is 1? There's actually only one angle, right? Pi over 2. One trip around unit circle. What are the angles where the sine of an angle is 1/2? It's actually two of them, right? It's pi over 6 and 5 pi over 6. So I think there are 3 solutions: pi over 2, pi over 6, 5 pi over 6. Let's see if that's correct. So here, number 10, now it has this thing where it acts for the smallest, the largest, and the middle. So for us, the smallest one is pi over 6. So pi over 6 should be first. The middle one, it's pi over 2. And then the largest should be 5 pi over 6. So with that in mind, let's go see what the answers are. And hopefully, that's what we're going to have. So pi over 6, yeah, 1/6 times pi. 5 pi over 6 is the largest, and in the middle is pi over 2. So it looks like it is correct. All right, so that was the first 10. How many of these are there? 29. Wow. So I'm going to stop now, and I'll turn this into a video, and it will pick up with number 11.